of Miriel, and we build a AI context engine for developers. We'll be talking more about that today. And in general, I've been building, scaling, and investing in startups for a very long time. So very much excited to chat with everyone today.
We're so excited to have you here. Thanks for joining us. Jennifer?
Hey guys, I'm Jennifer. I'm from Texas. I've been part of Protopia for a long time now. I'm a head of engineering, and my team works on building the stained glass transforms as well as all the core libraries to support you guys to build it yourselves as well. Thanks.
Amazing. Thank you. Nicholas?
Hi, everybody. I'm Nicholas DuPont. Some of you might know me as Nico DuPont. I'm the founder and CEO of Cyborg. I've been working on this for about the past 6 years, and we're building Cyborg DB, which is a encrypted vector store that secures AI model knowledge and memory. I'm really excited to talk a bit about Cyborg DB and in the larger context of Miriel and 9 Squared and Protopia today.
Awesome. Thank you. Okay, I am going to share my screen so you guys can see the Miriel security system.
9 Squared.
9 Squared. What did I say? Sorry.
Miriel system. Yeah, the 9 Squared one.
Excellent. All right, perfect. I found my demo. Now I have to find my realm screen again. Okay, here we go. Is that working?
Yes.
Yep.
All right. So before we get into 9 Squared itself, let me just paint a picture for you. I want to make sure that we're all on the same page about the problem that we're solving here. Imagine that you are the security director of a large mixed-use building. You've got 600 or more residential units, 100 or more camera feeds generating terabytes of video every day, and zero tolerance for data leaks. This is kind of the problem that most buildings face. Traditional cloud-based camera services like Ring, Nest, and all the enterprise security monitoring systems can really only do motion-based monitoring. There's really limited AI usage to filter out like leaves blowing around. If you've got a Ring camera, you're used to getting those alerts. And motion detection beyond that requires basically a human to manually review the events. In a large building with over 100 cameras, there are millions of motion events triggered every month. It's impractical to hire a team to review every event. So in reality, most buildings find ways to ignore all of the events, like just not monitor the cameras, or just pay attention during low volume moments, like at night. The entire security system ends up being used only for post-event analysis. So like after a break-in, they'll say, well, let's go look and see what happened, instead of the real-time detection and prevention that it's promised. So what if you want full coverage of real-time analysis? You would think AI could help with this. And it can, but we can't introduce another risk of the raw video footage being exposed on servers that you don't control. So 9 Squared solves this a little differently. Powered by Miriel, Cyborg, and Protopia, the entire process can run automated with end-to-end encryption that is encrypted in transit, at rest, and in use. It's even an option for the building to keep all of the raw footage on premises and run the system with full control and full retention of their data. And even in the scenario where you're sending footage off premises, 9 Squared will send encrypted video that is unrecognizable unless permission is given to decrypt. So I'm going to share kind of what that looks like to the AI model with you. There you go. So you can kind of see here, Protopia and Cyborg work to obfuscate the video and encrypt it. If a human or any regular computer were to get a hold of the video, they would only be able to see the threat detection features, posture, positioning, objects, while the rest of the footage is non-human readable. Without permission to decrypt from the building, you cannot reconstruct faces or identify individuals. However, to a computer with the right access, the system can operate unaffected. Your data remains encrypted while being used in real time to detect security threats. This is done for real-time threat analysis, sending alerts and forensic search across weeks of footage. Miriel is the glue holding all of this together, providing the right context at the right time to the AI system. It also allows instant policy updates with no retraining or involving machine learning engineers. So that's what 9 Squared delivers. I'm gonna stop sharing. What you just saw requires solving 3 distinct technical problems. The first is ingesting all of the data and querying against it, which is Miriel's specialty. The second is encrypting the vector embeddings, which Cyborg handles. And the third is running securely at inference time, which is Protopia. Josh, I understand Miriel makes it easy to ingest different data sources and bring the relevant context to the application. However, can you explain a little more about how Miriel plays a part here? And when somebody sets a new policy and the system enforces it immediately, what's actually happening under the hood there?
Absolutely. Thanks, Chelsea. So in general, like the approach that we're taking is quite different. Like thinking about the traditional approach, someone's going to be retraining a model. That's how ML models have worked for many years, and even large language models. You're using a large data set to be able to train a model. And that fundamentally is just not going to work here for a variety of reasons. And one of those is that you need real-time analysis. What happens when you have new data that comes in? So you saw in the video, it kind of went by pretty quickly, but adding a policy such as, I think it said, like, there should not be any packages in the lobby. If you were to add that and you had to go retrain the model, it would take a really long time and it would be really expensive. And so the other component here is also security. And if you think about security with an LLM, which is probabilistic, you would never want to put sensitive or private data into that training set, because as a probabilistic model, it could potentially leak. You wouldn't want to put your social security number, for example, in a training set and then have someone say, hey, could you tell me a bedtime story about Josh's social security number? And it might actually come out. So it's just the wrong approach, and it doesn't work for a security situation like this. And so what Miriel has done is fundamentally different. We've built a context engine, and that context engine is essentially taking and connecting to all your data to an AI model, such as an LLM. And that way you can ground it based on your data and give attention to what's relevant. And you can call and pass that information to the LLM and do things that you couldn't really do before. And so like we saw in that 9 Squared example. And so I think it'll actually be a bit easier if I can just show you some of the code, and I'll actually just kind of recreate the prototype of how you build 9 Squared with Miriel. So let me find the share screen here. And I'm going to share my entire screen, so we'll see how that goes. Hopefully, can you see a code editor?
We can see it.
Awesome, cool. So in general, what we have here is a very simple way to build AI applications, and Miriel is really meant to be just 2 functions. One is to be able to learn data, and the other is to be able to query. And so here we can see the learn statement where we're connecting to your data. And this is an RTSP feed, so it handles anything from video to audio, text. It's multimodal, it handles real time. And so all you had to do is just point it directly at your data. In this situation, it's an RTSP feed, and Miriel figures out what to do with it. And so that one line of code is actually looking very simple, but very, very powerful. Underneath, what it's doing is it's taking all of this, breaking up frame by frame, and indexing that into 3 different spaces. The first is a vector database. The second is a knowledge graph. And the third is a more traditional relational database. And that's really important because there's different things that each is good for. And you have to be able to then pull from each of those to find that relevant data and retrieve all of the relevant context. And so now when we want to do that, what Miriel does is you use a query. And so we write a simple query like this. And it actually looks simple, but is also very, very interesting of what is happening under the hood. And so it's doing more than just semantic comparison. And so we actually have filtering. And so we said something here like, show me all the non-food deliveries at the main entrance last week. So it's going to use that traditional database to start filtering things and saying more like a SQL style filter of just show me the stuff from last week. And then if you want to add relationships and entities, so the main entrance is a concept or a node that you would be able to understand and say, I just want to see the cameras from the main entrance. And then also you've got reasoning on the data. And so we want to look at all the deliveries that are non-food related. So show me all the packages that showed up. And that was the example in there that we were setting a new policy about packages. And so this query is kind of doing something that traditionally hasn't been able to be done with traditional retrieval methods, where we have a lot going on and you're able to do enhanced queries that you couldn't have done before. And you're reasoning across all of your data. And now kind of getting back, connecting to your original point about the policy of we're introducing now new information or a new data. And so we would do that in the same way we did before, which is just with another learn statement and calling learn. And you've got a new policy here. The new package should be kept only in the lobby. You don't need to retrain anything. This does the exact same thing as before. It indexes it into the vector database, the knowledge graph, and the relational database. And that way, when you make a new query, such as about these packages, or alternatively, the real-time threat analysis, which is what's the current threat of the building, or is there any policies out of violation, any query that you might want to ask, that new policy is already indexed and ingested into Miriel. So that way you'd be able to just get the most relevant information and pass that to the LLM and then work with it. So I'll stop sharing now. There we
That
go.
is too cool. So you're taking the policy that you just created as an embedding and comparing to the embedding from the frame of like packages being in front of the desk.
Yeah, exactly. Yeah. So essentially, that policy and everything else, the metadata, the video stream, everything's in the same effective space, or we're pulling from different spaces and combining it. So that way you can assess that current threat. So it's all just in the same embedding. And then that allows you to do very interesting things. And you pass whatever is retrieved to a large language model to be able to synthesize and create that threat analysis. You don't need to organize anything. You don't have to label your data. Miriel just automatically handles all of that for you.
Sounds insanely good. My next question is, what is the storage footprint like for storing all of that context?
Yes, many people have heard that methods like this could be gigantic, but the good news is for something with images, for example, we're actually in 9squared's deployment, we're actually seeing about 2 to 5 gigabytes of vector embeddings per camera per month. And the reason why it's so lean is because you're not indexing pixel for pixel. You're condensing it down into basically a 768 dimensional embedding vector space. So it actually can be smaller than the original video, which is kind of cool.
That's awesome. And then when you add a policy, you mentioned that is instant. What does that mean? What does instant mean? What is the latency there between adding a policy and being able to use it?
Yeah, we see around 50 milliseconds from the time that you're submitting. I mean, it depends on what you're doing, but for a policy, for example, it'd be like just 50 milliseconds. If you were doing a brand new gigantic, terabyte size file or something like that, it might be a little bit different, but it is still pretty fast. And there's no batch jobs, there's no overnight retraining. It's all immediate and available for you on that next threat assessment. And that's honestly Miriel's role here for 9squared. It's just incredibly easy to build very powerful AI native applications with the ability to add real-time data and analysis as whatever you need.
That is super impressive. Okay, well, my next question is, all of those embeddings contain sensitive data representing real people in real buildings, which brings us to Nicholas. When Josh's system is generating these embeddings of people's faces, their behavior patterns, their movement through the building, this is incredibly sensitive data. What happens if that vector database gets breached?
Well, that's a great question. I wish I was asked that question every single day. It's honestly something that most security leaders should be should be really worried about. We think it's going to be one of the biggest breach vectors for a lot of these AI applications in the near future. Something that most people don't know is that vector embeddings are invertible. They're not anonymized. They're not, one-way hashes or obfuscated representations of the data. They are dense representations of context, of semantics, of meaning for that modality. And so it means that because you're able to encode meaning into it, you can decode the meaning back out of it. It's actually relatively trivial. It's been shown many times in academia. We've shown it ourselves at Cyborg a lot. And so that means that if somebody steals your vector embeddings, or if they get leaked, they get exposed, they have access to the original data. You have to treat it with the same level of sensitivity as that original data. And when you're dealing with, security camera feeds that contain, biometrics, people's faces, their whereabouts, etc., that's hugely sensitive. Not from a security perspective, from a privacy perspective, not to mention from a compliance perspective in various geographies. And so the type of security risk that is brought about can be pretty big. And if you're using a standard vector database that is unencrypted, you are essentially waiting for a disaster to happen.
How do you search encrypted vectors? I understand that you need to decrypt your vectors to search them.
Yeah, I mean that's kind of the secret sauce, right? That's why we're here. So CyborgDB is built on a principle called forward secure cryptographic indexing. So CyborgDB, as I mentioned earlier, is a encrypted vector store. It's essentially an application layer encryption for AI knowledge and memory. So as we mentioned, AI applications use vector embeddings that are as kind of their lingua franca, and our role with CyborgDB is to encrypt them and then make them still available for use at inference time. And the way that you use them, in the case of a RAG pipeline like what Miriel makes so easy to build, is to be able to do search, to be able to do semantic search. And so with our cryptographic indexing, we essentially take these vector embeddings, we cluster them, we quantize them, we do a whole set of techniques of dimensionality reduction to be able to essentially take them from a wide space, 768 dimensions or larger, to a smaller discrete space. And then we apply our cryptographic indexing scheme where we essentially create an HMAC seed from a master index key for each one of the clusters. And then for each occurrence of a vector embedding within that cluster, after being quantized, we create a unique ID and an encryption key for that embedding that is rotated through a binary tree using the SHA-3 cryptographic algorithm. Now, I know this isn't a session about cryptography, so I won't go too much into it, but essentially the result is you take these vector embeddings, IDs, metadata, content, and you then have just ciphertext. And at query time, at inference time, we're able to regenerate, find just the closest tokens, the closest embeddings in that binary tree through that pre-clustering, generate just those, retrieve those back out from the backing store, from the database, the closest ones, and then return them back to for the LLM to be able to take action off of it. So it's kept encrypted in use.
That sounds very clever, but also like a lot is going on there. What is your latency?
So essentially we've targeted and we've reached sub 10 millisecond latency across basically every workflow. Obviously, like everything, the answer is it depends. So as the dimensionality of your embeddings get larger, you have a larger cost computationally across any vector search algorithm. That's the case with us as well. But we're able to, in the case of the application with Miriel and 9 squared, we're able to, cross well over 1,000 queries per second, meaning that we are on a per query basis, in the single digit milliseconds of latency. So there's not a significant overhead introduced, and on the end-to-end impact of a RAG pipeline, it's essentially negligible.
That is awesome. Okay, let's talk about the compliance angle. I know a lot of people building in AI and healthcare, finance, and government cite data privacy as the reason that they can't adopt these systems. How does CyborgDB change that calculation?
Yeah, it's security for enablement. That's what we've been calling it, and a lot of people in the space are as well. Essentially, in order to be compliant, firstly today, if you want compliance with AI regulations, you're out of luck because there's basically no AI regulations. It's still being figured out. The government's lagging on that a little bit, but you have to consider the first principles of how you're going to build what might be a compliant application, and security is at the heart of it. And with AI, there is no such thing as security at the perimeter anymore. It's your data is everywhere all at once, and you need much more granular zero trust approaches to security. And so that's where architecture really matters. And that's where we built CyborgDB, and supporting models like bring your own key, hold your own key, having your own encryption keys that you're able to assert sovereignty over your data by controlling them, so that wherever that data may be, only you are able to access it, only you are able to query, only you are able to run inference and drive value with it. And so that's a great principle from a security perspective. But from a compliance lens, it means that you are reducing the amount of exposure to the maximum degree and able to make it much more easy to comply with regulations around data sovereignty, right to be forgotten, so on and so forth.
Awesome. So you're enabling the RAG pattern while maintaining a zero trust architecture.
Yeah, that's a great way to put it.
That's awesome. We have a question in the chat. Do you see this as a Pinecone competitor or a more niched down offering?
The answer is we are operating in the same space. Absolutely. We are, providing an encrypted vector store. For those that are not familiar, Pinecone is a fully managed vector database. We are very much focused on the security and privacy angles today. So there's definitely a niche aspect, but we believe that security will be a requirement in every single AI application in the future. So that's my diplomatic way of saying yes.
Thank you. All right, so Miriel gives us the ability to instantly add new data and query against it. CyborgDB gives us encrypted retrieval, but there's still a moment of exposure that we have not addressed when the large language model actually processes the data. Jennifer, this is where Protopia comes in. Can you help us understand the inference problem? Nick showed us how to keep embeddings encrypted during retrieval, but when you feed context to the LLM for reasoning, doesn't it have to see the plain text?
Mute button. Yeah, I found it. So yes, this is where the structure gap in AI security comes in today. You can encrypt data at rest and you can encrypt in transit. But the moment that that data reaches the large language model for inference, systems have to decrypt it. So think about what happened with 9square. When the threat assessment engine runs, Cyborg retrieves relevant encrypted embeddings, and those get decrypted to feed the LLM. The LLM generates that threat assessment based on the plain text descriptions of what it sees. And that response is encrypted again for transmission. So imagine instead of having to do that, you could transform that data so you no longer have that risk anymore. So this is where AI systems are vulnerable. If you use a managed endpoint, such as Amazon Bedrock or even self-hosting, your data is in plain text on somebody else's infrastructure during those critical milliseconds. So for enterprise AI, that is unacceptable. You're relinquishing control of your data and effectively trusting providers, their employees, their security practices, and their subcontractors with your most sensitive data. And so Protopia eliminates the plain text exposure during inferencing.
Sorry, go ahead.
So the key insights is that the large language model are remarkably robust to data transformations. And we don't decrypt, we don't encrypt in a cryptographical sense, we transform. And this means that there is no decryption needed for the LLM to operate on this data. So our technology is called stained glass because it's people like to think about, like we saw the video feed of the people running in. Imagine looking through it where you can't tell what's happening, or maybe you get but the model can still understand that information is still in that data, but it's been protected in such a way that if it was to leak, somebody wouldn't be able to interpret that data. So the LLM processes those transformed embeddings. And when we transform those embeddings, they're actually stochastic. So that means if you were to send the same thing multiple times, those embeddings would be different every single time. And we provide support for the end user to encrypt the output as well as it being generated at inference time when the end user provides their key. So here's the critical part. The transformation is a lightweight trained model. We have different levers you can choose that controls the model's utility versus the data privacy. And this means that you can create a SGT for your specific use case if desired.
Awesome. How are you doing that? So you're obfuscating the video. The model still understands it. How does the model still understand it if it's not plain text anymore?
Yeah, so our stained glass transform is actually a model that you create that is trained for that downstream model. So in the example, if it's a computer vision, if it's an object detection model, that stained glass transform learns how much it can how to obfuscate the data so that the computer vision model, the object detection, can still understand, but that the data is no longer understandable to anyone else.
So I heard you say that the accuracy, there's an accuracy utility trade-off, but generally, what is the accuracy hit?
Well, when I say trade-off, you can tune that, but generally, you know, it depends heavily on the use case. But for most enterprise applications, we're seeing less than a 5% degradation. And where this really shines is in scenarios like healthcare, running diagnostic models on medical imaging where patients' identity must be protected, or finance for fraud detection on transaction patterns without exposing account details, or even code gen. We have commercial and government customers like BugCrowd and the US Air Force using stained glass to enable developers to use code LLMs without actually exposing their code bases.
That's awesome. Do you have any other video examples?
Yeah, so that's a really interesting example that we did with the US Navy using stained glass to run a very important person detection during their Trident Warrior exercise. They had a computer vision model turned up to detect individuals running on a live video stream. And in a real world scenario, maybe you need to run that detection model in an environment that you don't have control over. So for that exercise, they used stained glass transform to transform the footage, which was sent to a detection model to pick out the key individuals without ever exposing that footage in the process. That's the future of AI in regulated environments, utility without exposure.
That's pretty crazy. All right. Awesome. All right. Well, let's talk about the architecture integration. How do Protopia, Cyborg, and Miriel actually work together in a system like 9 squared? I'm going to share an architecture diagram. Can you guys see that?
Not yet.
You can't? Can you see it now?
No.
Nope.
Okay. I'm learning my way around. Let's see. Can you see it now?
Yes.
Yay. All right. Excellent. So I want to make sure everybody walks away understanding not just what each one of these companies does, but when these different pieces are useful in your system. So let's go ahead and map the data flow. Josh, can you start us off at the ingestion layer?
Yeah, for sure. So we're taking everything and we're being able to first get it into Miriel. We're ingesting it. That's all the indexing and everything else. And we've got over 100 cameras at this building here, and it's all streaming video. And so Miriel is actually doing something in this case, which is like frame extraction, and it's adaptive frame extraction. So it can allow you to have one frame extracted when nothing's happening, and then you can like ramp that up when motion is detected. So that way you don't need to do any sort of special computer models, no vision models, anything like that. It's all just video frames, metadata, the timestamps, the logs, anything that you want to ingest. All of that data is just easily called into Miriel. And so everything gets ingested inside of the Miriel context engine, And that allows you to then query against it, retrieving particular parts of the data that's contextually relevant based on the query.
That is too cool. All right. And so then that is where Cyborg comes in.
Yep, that's right. So we take those the query embeddings or the input embeddings that are generated and at the time of indexing, we encrypt them. We take the embeddings, the IDs, the contents, the metadata, anything that's fed to us, and it gets encrypted client side. In this deployment, it's using bring your own key. So the encryption keys are held on premises, and then our CyborgDB proxy handles the encryption, does that cryptographic indexing that we talked about, and then stores the encrypted embeddings out to a commodity backing store, like Redis in this case, I believe is what we were using. And then all the encrypted metadata, the timestamps, the camera IDs, event types, etc., are all stored there, and we support encrypted metadata pre and post filtering, and so keeping all of that data encrypted.
Awesome. And then it looks like the query and the context get sent through the Protopia stained glass transform.
Yeah, so stained glass transform is the model that we use to transform your data. We run it inside what we call a stained glass transform proxy. And so think of it as a OpenAI compatible API. So if today you are using whatever downstream inference engine, you're probably using OpenAI calls to do chat completions or a completions request. And so we are a drop-in replacement where you can, with a few, actually with just changing the URL, that query and that context that you would originally be sending to that LLM as plain text or whatever that you're sending it images, you send it through the stained glass transform proxy. We then transform it, the embeddings, and those embeddings get sent to that downstream LLM. In this diagram, right below where you see the SGT transformed embeddings, is actually showing an example of a reconstruction. So if those transformed embeddings were to leak and somebody was to try to reconstruct them or try to make out what the data is, in an example of a nearest neighbor search, you can see that it's going to look like garbly glook or something that's not going to anywhere represent what the original query or context was. And then that response is returned to proxy, which then returns to the caller that called proxy. In this diagram as well, we have a output protection plugin that we can provide so that it adds another layer of protection that if you wanted to provide your own key during the request, you could protect the responses and only you hold that key, then you can decrypt it on your side.
This is so cool. This is like real private AI by design from the beginning. I love it. Okay, so I'm going to just run through this architecture right quick. So we've got ingestion where the video and all the other contextual data is indexed by Miriel without the need for any computer vision models and is turned into embeddings. And then we have storage. So embeddings go to CyborgDB. They're encrypted at rest and during search. And then we have retrieval with multimodal context plus policies retrieved by Miriel in milliseconds. And then Protopia protects the inference part. So transform data is sent to the LLM. The plain text is never exposed. And then we have the output. So clean threat assessment plus explainability, each layer solving a distinct problem. And let's talk about, I guess, when you need each one. So for all the folks out there, Josh, can you tell us when they would use Miriel in their own applications?
For sure. So Miriel, honestly, you'd use it whenever you're building with AI. Miriel can help. And we aim to really make it as simple as possible and as fast as possible to build any AI feature or app in minutes, maybe hours, but certainly not months. And not only do we make it easier and faster, but we also allow you to do things like build a 9 squared application with the LLM as the core logic of your application. And that's something very different than what a lot of people are building today. And in addition to that, we work with text, images, audio, any data you want to throw at us, real-time streaming video feeds. We're agnostic to your vector database, your LLM, your cloud provider. It's kind of natural as a platform. And at its core, we're a context engine. And we believe context is everything.
That is amazing. I also believe that, and I would not have handled it so cleverly. So that's awesome. And then Nick, when do people need Cyborg DB?
Well, if you're building in regulated industries, healthcare, finance, government, et cetera, in multi-tenant environments where data isolation is critical, or any scenario really where vector embeddings are generated from sensitive information that would violate compliance if leaked or be, a big problem for you. Or even if you just want a zero trust architecture in non-regulated environments, CyberDB generally just eliminates a huge attack surface.
Yeah, I definitely feel like people underestimate the amount of sensitive data that they have. I saw an article earlier this week about Sora. People make their own little avatars and they discount that Sora also can see the whole background of their house. Stuff later shows up in videos like your trade secrets are like in these models. All kinds of really sensitive data goes into these AI applications. So we should all be thinking about security and privacy all the time. Jennifer, when do you need Protopia?
Yeah, so you pointed out a good question, or not a good comment about trade secrets and stuff. One of the benefits about using these LLM models, the better, the richer the data is, the more information, the higher accuracy that you're going to get in the response. And so with traditional approaches where people are trying to do tokenization or redaction, you are limiting your data, and that could be a good or a bad thing. But how do you identify what is a trade secret, or sending more data than is actually needed, and along those lines? So our approach is why we can work in conjunction with those. It adds this additional layer, so where you still own and retain the data that you're sending over, but you're limiting the vector of leakage with that data that you're relinquishing to wherever the LLM is running. And so a lot of people are finding benefits for using stained glass to help protect them. The other thing is, with a lot of people who want to have that additional layers of data privacy or protection, they'll find the answer of, oh, I'm going to run LLM internally as a standalone or something along those lines. And that takes a lot of time, people, and resources, where with our approach, we're actually improving your return on investment, because we're allowing people to either use more data that they generally wouldn't, and so they're getting better results, or they're sharing resources because now their data has been protected and they have trust and will use a cloud offering such as SageMaker or something along those lines.
Awesome. And just to clarify, do I always need to use Protopia, Cyborg, and Miriel together, or can I just use the ones I need?
So obviously, I think it's the perfect trifecta. So why wouldn't you use all of them together? But that said, all the systems are designed to be modular. So you could use Miriel without Cyborg DB if your data is not sensitive. You could use Protopia without Miriel if you're really just focused on private inference. You could also use Cyborg DB and bring that to your existing system. But as I said, it is a perfect trifecta. And if you're deploying AI into a production environment, why wouldn't you want to build a really powerful application that's fast and secure? Compounding the effects of Miriel, Cyborg, Protopia is to production grade security is really awesome. So if you're already building with Miriel, for us, you just have to turn on Cyborg and turn on Protopia, and you've got all three of them working together.
Amazing. Okay, we do have a couple of questions in the chat. I think this question is for Jennifer. What kind of model performance impact do teams typically see when they're running inference on obfuscated visual data?
So in the past, when we've done actually visual data, depending on many factors, how much training data does the SGT see when you create it, what type of model do you use, along those things. But I believe in some of our test cases, you see like maybe a point difference give or take based on the model performance. But again, that's all factors that can be changed or tuned depending on the data that you use, the model that you're going to use, how much, what you're sending it, things along those lines.
Awesome. Okay, we've got about 10 minutes left. We've been answering questions as we go. We can definitely take a few more. There is one here that I'm not sure if it was directed at Cyborg or Protopia. But the question was, is there a paper about this?
I saw it come through when Jen was talking, so I think it was for you guys.
Oh, well, I will answer the question then. I believe there are lots of papers for Protopia and for Cyborg. We're happy to share them. We have a white paper on our site. We have a couple technical papers. So yes, there are papers and we can share them afterwards.
Awesome. Thank you. You can always find us at cyborg.co, Miriel.ai, and protopia.ai. I think that's about it. So if we don't get any other questions in the chat, we're always happy to follow up with you guys afterwards. You can reach out to any of us. You can reach out to me directly and I'll field questions. But thank you so much to Jennifer, Josh, and Nicholas for joining today and for the great panel discussion. I think we all learned a lot about building AI with privacy and data security by design. And the audience really came away with a lot. So thanks everybody who joined today. And thank you to AI Collective for helping us produce and promote today's session.
Thanks. Bye, guys.
Thanks, everybody.
Yeah.
Yeah.